We've learned the synthetic division process. Now let's put it to work for us. So we've got a new theorem called the rational zero test, and it tells us that for any polynomial function, we could list all of the possible rational zeros. Remember, the word rational means you can write it as a fraction a over b, where a and b are integers. So this is a pretty exceptional theorem. It doesn't tell us the answer, but it gives us a list to choose from. And the possible rational zeros are of the form the factors of the constant over factors of the leading coefficient. So look at this example. Our constant term has several different factors. Negative 8 could be divided by positive or negative 1, positive negative 2, positive negative 4, positive or negative 8. So the factors of the constant, and then we're going to combine those with factors of the leading coefficient. Well, the coefficient doesn't appear to be here, so it must be a 1. So the leading coefficient is the coefficient of the highest degree term. Well, we like this one because our denominator is either going to be positive 1 or negative 1. So we take all of the possible fractions that we've just listed here. So our possible answers could be 1 over 1, and it could be positive or negative, 2 over 1, and it could be positive or negative, 4 over 1, or 8 over 1. So that means that there are 16 different numbers we have to try. So you might not want to do 16 synthetic divisions, but there might be some hints. And here's the best hint that I can give you. Look at the sum of these coefficients. Go all the way across and add them up. 1 plus 5 plus 2. Notice that's equal to positive 8 minus 8. When I add up these coefficients, I get 0. And what does that tell us? If the sum of the coefficients is 0, then 1 is an answer. So then 1 is a 0. So of our entire list here, the easiest choice for us to make is when we set up our synthetic division, we believe that when we do synthetic division by 1, we are going to get a 0 remainder. And there it is, our 0 remainder. So sure enough, when the coefficients add up to 0, then 1 is going to be a factor. So what have we just figured out? We have solved our problem. Because if 1 is a 0, then x minus 1 is a factor. And the remaining coefficients, look at your synthetic division results, x squared plus 6x plus 8. Once we get to a quadratic, you can either factor it or you can go to quadratic formula. And we can see the factors here. So our 3 answers, so here's f of x in factored form, and our zeros of the polynomial then. Each one of these gives us a 0, and they could be x equals 1, x equals negative 4, x equals negative 2. If you write that as a solution set, then it's nice if you put them from smallest to largest. But either form of your answer is perfectly fine. So the rational zero test doesn't tell us an answer, but it tells us the list of numbers we should try. So here we were lucky that we had the sum of coefficients equal to 0. In our next example, that's not going to work. We're going to have to do a few more trials before we might hit the jackpot. Okay, before we do another example, a couple important theorems. This one is called the fundamental theorem of algebra. Can't sound much more important than that. The fundamental theorem of algebra. And it says that every function defined by a polynomial of degree 1 or more has at least one complex 0. So what does that tell us? It says every polynomial has at least one answer. And what form could they take? Complex numbers. Remember that a complex number looks like a plus or minus bi in standard form. So we could get a complex answer like 3 minus 2i. But remember that subsets of the complex numbers, we could have a rational number. And a rational number is complex because it could look like 7/3 plus 0i. So when we get rational numbers, so we could get 15 as an answer or -1 as an answer. Those are all rational numbers. Or complex numbers can also be irrational. So we could get answers of the form 2 plus 3 square root of 5, or we could get an answer like the opposite of the square root of 2, or we could get an answer like 7 radical 3. So we can get all kinds of answers, but the fundamental theorem says we're going to get at least one answer when we try to solve a polynomial function. So we just have to be patient in order to find them. All right, and then we have one more theorem. The number of zeros theorem says that a polynomial function of degree n has at most n distinct zeros. So distinct means different in appearance. So, for example, remember that a function like x minus 3 quantity squared equals 0 only gives us one answer, but remember we said that it was a double root. So that means it has only one distinct looking 0 because 3 shows up as a double root. Okay, let's go back to our rational zero test and try another problem. So these are like puzzles. Don't give up. Keep trying. So this example, look at our coefficients. 15 plus 61 plus 2 plus -8 definitely does not add up to 0. Remember that hint. It's going to save you homework time. If the coefficients add up to 0, then 1 is going to be an answer. But these coefficients do not add up to 0. So what could be all of our roots? Well, remember we take the factors of the constant. So what goes into -8? 1, 2, 4, 8. Divided by factors of the leading coefficient. Ouch, look at all the choices here. The factors of 15, 1, 3, 5, 15. So what are all of our possible zeros? Holy cow. 1 over 1, 1 over 3, 1 over 5. This should be 1 over 3, 1 over 5, 1 over 15. And we start with the 2. 2 over 1, 2 over 3, 2 over 5, 2 over 15. And then we go to 4. 4 over 1, 4 over 3, 4 over 5, 4 over 15. And then we still have to do plus or minus 8 over 1, 8 over 3, 8 over 5, and 8 over 15. So I don't even want to count how many choices there are. So we might have to do synthetic division over and over and over again until we can get a remainder of 0. So where should we start? Well, we could set up our synthetic division. 15, 61, 2, -8. So you could start with any of these numbers. So you could pick your favorite one. You could say 4 over 15 is my favorite choice, and then you can do synthetic division. But I'll tell you that I think most of us would say, let's try the integers before we try the fractions. But there's no guarantee. So pick your numbers and start dividing. So you might say, I'm going to try 2. I know that +1 doesn't work, so I'm going to try 2. That doesn't seem so difficult. And as soon as I get to this point, do you see that you really are way off track? So if you're using a pencil, you might save some paper and say, you know what? I'm just going to try -2 instead. So I think that might have a better chance because the negative might cancel out with something. But again, as soon as I get to this point, I can see that it is definitely not. To get a 0 here, we would need a positive 8. And you can definitely see that that is not going to happen here. So as soon as you see that you're off track, you might just say, I'm going to press on and try something else. All right? So I know that plus and minus 2 did not work. So I'm going to be optimistic and hope that either positive or negative 4 might work. So set up another, not 16, 61. Set up another synthetic division, and I'm going to try 4. And I like what's happening here because I get 60, but it's got the wrong sign. So you can see as soon as you would add up to 121 that you're getting way off base again. But I think if I make this negative 4, that might get us onto the right track, because then we'll have a negative 60. That'll bring down a 1. We'll put a negative 4. And there we go. We have hit the jackpot. We get a 0 remainder. So the authors of the textbook could be really mean and have only fractions as the answers, but if you're really lucky, you won't have to do too many trials. So as soon as I've gotten 0 as a remainder, now look at what we know. We know that f of x, which was 15x cubed plus 61x squared plus 2x minus 8, I now know that it has negative 4 as one of its zeros, and that means that x plus 4 must be the factor. Remember that negative 4 comes from setting this equal to 0. And the other factor, I look at my remainders, or my synthetic division answers, 15x squared plus x minus 2. And if you don't immediately see the factors, then you could go to quadratic formula. If you really like synthetic division, you could set up another synthetic division and keep trying that way. But I suspect that this just might be a 3x and a 5x, so I would at least try factoring before I go to quadratic formula. The reason I think this is going to work is because I see a 6x on the outside and a 5x. So if I make the 6x positive and the 5x negative. So there's my answer for the factored form. I have found all of the factors, and then the zeros come from setting this equal to 0, and I might need some space to work here. So I set x plus 4 equal to 0, 3x minus 1 equal to 0, and 5x plus 2 equal to 0. And you don't have to show that step. You can solve these. Move the 1 to the other side, divide by 3. Move the 2 to the other side, it will be negative, divide by 5. So you can leave your answer in equation form. These are our 3 zeros. Or you could write it in a set notation. And it would be nice, not required, but nice if they were smallest to largest. So with some work, you'll be able to find the factors, but it might take a lot of tries at synthetic division. So perseverance, think of them like puzzles, and do not give up till you find one of those 0 remainders.